let's play with simultaneous, if I can get the word out, simultaneous differential equations. So we have got a paired system of first order differential equations that we need to solve. All right, we've got their initial conditions. Let's do it, let's go. First of all, we're just going to differentiate one of them. So let's differentiate the first one, which tells me that d2x dt squared plus 2 dx dt is equal to 4 dy dt. And you could be forgiven for saying, but Nick, why would we do that? Well, let's substitute that back in. Let's substitute the second one in. d2x dt squared plus 2 dx dt is 4 times 5y minus 3x. And you could be forgiven for going, but Nick, now we've got y's in there, so what are we going to do? First, we're going to tidy this up. Oh. Plus 2 dx dt is 20y, and in fact, let's move that over, plus 12x is 20y. But don't fear, I can substitute that one back in. d2x dt squared plus 2 dx dt plus 12x is equal to, let's just times that one by 5 dx dt plus 10x. So what we end up with is d2x dt squared minus 3 dx dt plus 2x equals 0. And now, nice and easy. That is lambda squared minus 3 lambda plus 2 is 0, which gives me lambda is 1, lambda is 2. So we know that, in fact, x is going to be a e to the t plus b e to the 2t. Now notice I'm not trying to get a and b yet, right? Because essentially this is a second order differential equation. I only have one initial condition for x, so there's something else going on. So what we need to do is leverage the fact that I have two conditions, one for x, one for y. So we're going to hold on to that, and now we're going to go look at dy by dt. We could do the whole thing, but we've already got something here for x. Now, what this means is we can plug that into here. So if we rearrange this one, the second equation, dy by dt minus 5y is equal to minus 3a e to the t minus 3b e to the 2t. All right? Or more importantly, so that's one option, and we can solve this, right? But you've already got something here. So how about we have a look at this one? dx dt is a e to the t plus 2b e to the t. Let's plug all of that into here. So a e to the t plus 2b e to the 2t plus 2a e to the t plus 2b e to the 2t is 4y. And now we are up and running. So we do know that y is 3/4 a e to the t plus b e to the 2t. Epic. So we do have a few options. You could just do the entire first process from scratch to get second order there for y, but we're going to have a real hard time in terms of the a's and the b's. You could take this expression and plug it into the equation for y, which sort of feels like something we might want to do to solve for y, but we still end up with a differential equation that I don't like the look of. So in fact, we're going to take our solution for x and plug it back into the x equation to get directly an equation for y. Now we can plug in our initial conditions. When t is 0, x is 0, y is 1. So when t is 0, y is 1, and x is 0. What if we subtract this one minus that one? I get minus 1 is a quarter a. A is negative 4. And then b is 4 from this one. So what we get is, and this is where we can get a little bit funky, xy is a for x, which is minus 4, 3/4 of a minus 3, e to the minus t, plus 4, why e to the minus t? It's just e to the t, e to the 2t. And that is my solution in vector form. I quite like it. And there you go. Linked, simultaneous, first order differential equations. Easy peasy, squeeze the lemon. Don't forget to click like and subscribe, hit the bell for notifications, and basically tune in next time for some more lovely gooey maths goodness.